Alright, so today we're going to review histograms and also talk about how to read them and how to describe their shape using socks. So how many of you are familiar with histograms? Well, not quite so much as yesterday, right? I think once we do them, you'll realize you've done them before. There is one error on this sheet that I'm going to have you fix shortly, so remind me if I don't mention it that you have something to fix. But we're going to use the data below to complete the frequency table. This is your frequency table right here. This table is used to help you organize all of this data into what's known as a histogram. And a histogram essentially is, it looks like a bar graph, but there's no spaces in between the bars. The bars are all touching each other. It's really no different than if we did a stem and leaf plot and turn the stem and leaf plot sideways, or so that the leaves would be facing vertical. We can create a histogram using a stem and leaf plot just as easily. But in a histogram, we're going to use what are called intervals. So unlike the dot plot that you did, where you had to count for every individual piece of data, here we're going to count for intervals. So that is similar to your stem and leaf plot. Didn't we do intervals with stems? We had like the 10s, the 20s, the 30s, the 40s. Well, that's very similar. So we've got data ranging from, in the, 11 my smallest piece of data, to 40, right? We don't know what the data is about. I don't know if it's test scores. I don't know if it's speed limits, phone calls, plant growth. I have no idea what it is. So I will not be able to make a title for this histogram because I don't know what it is. So at most your title would be histogram. But generally your intervals are going to go down here on the x-axis, and your frequency, how many items are in that interval, is going to go here. So the difference is in the histogram I can't tell what the individual pieces of data are like I can in the stem and leaf plot. All I can tell is how many are in that interval. So it's not as clear as a stem and leaf plot. But probably we really only care about the frequency if we're going to make a histogram. What's nice is I can just tally. I don't have to range these from smallest to largest. Just start with 20. 20 is going to go in the interval 16 to 20. So I'm going to put a tally mark, which is like a little toothpick, right there. Bless you. And I cross out my 20. Then my 32 belongs in this interval 31 to 35. So I'm going to put a little toothpick. 36 belongs in this interval. 11 is in the first interval. Once you get 4 toothpicks, your 5th toothpick goes as a diagonal. So you want to group your toothpicks in groups of 5. That way it's easier for you to count. If all you do are toothpicks all along there and you don't put a diagonal cross on the 5th one, you're going to lose count of your tally marks. It'll be very easy. So just be careful. I feel like I'm in a race. Who's going to come out first? So when you finally hit the 37, that last interval should end up with 5 in it. So that's what your groupings of 5 should look like. So that diagonal one counts as a toothpick. Now I'm not going to count my tally marks in total like we did with our leaves. What I'm going to do is count my frequencies and then see if that adds up to the total number of data items. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Is that correct? 23 total? Somebody count it and double check it. $23, yes? Okay. So then let's count our frequency. How many are in the 11 to 15 interval? 4. How many are in the 16 to 20? 4. 21 to 25? 1. 26 to 30? 3. 31 to 35? 4. And then 36 to 40? 7. So unlike a bar graph, we're not going to make pretty colored bars. All the bars are going to look pretty much the same. But let's add this up to make sure we have 23. So 4 times 3 is 12, 13, 16. What's 16 plus 7? 23. So our total agrees. All right, so over here on the side, on the vertical axis, we're going to label it as frequency. And our frequency goes from 1 to 7 is the highest, correct? So if I were you, this is 0. I would just label every other one. So this is 1. If you try to label every single one, it gets all gunked up. So this one will represent 2, 4, 6, and then 8. All right, then down here is our interval. Now, if I knew what the data represented, like let's say it was test scores, I would still put interval and I would put test scores in percents or something like that. So I would describe what these numbers, these interval numbers are telling you. I can't describe it, so the best I can do is interval. So I'm going to use 2 columns for the width of my bar. Oftentimes you'll see intervals marked off this way, kind of at a diagonal, mostly because it's too hard to fit 11 through 15 across and get them all in. So that way I could put 11 to 15 here. Bless you. And then again, we don't want any spaces, so then 16 to 20 will go here. And then 21 to 25. 26 to 30. 31 to 35. And then 36 to 40. There's nothing that says you have to use the entire grid that you've been given there. So now you have to use your straight edge. Do not hand draw your bars. So our first interval, 11 to 15, has a frequency of 4. So I'm going to draw the top of my bar first, which is right there at 4, and then my side. In order to see the bar, I'm just going to draw some diagonal lines to the bar, that way. So there's the height of my first interval. Then do your second interval. 16 to 20 has a height of 4 also. So since these bars are next to each other and there's no space in between them, I'm going to put my diagonal lines that are through the bar going in the opposite direction so that you can tell the difference between the 2 bars. So I'm going to put my diagonal lines going this way this time. Makes them look slightly different. You can tell the difference between them. Bless you. And then my third interval of 21 to 25 only has a height of 1. So it's a really small one. So I'm going to put my diagonals again the opposite direction as the previous one. And then 26 to 30 is a height of 3. And again, my diagonal is the opposite direction. And then 31 to 35 is a height of 4. Diagonals in the opposite direction. And then the last one has a height of 7. And that's what your histogram looks like. Now we're going to talk about the shape of the histogram using socks. And we're going to talk about measures of central tendency. So as soon as you all are in the same spot as me. Kind of look around you and see if your neighbor's looks like yours. Everybody should look like mine. So there shouldn't be anything completely different. What would happen if I had, could I have changed my scale and every horizontal line could have been a half? Could I have done that and stretched the bars up? Sure. But you have to label your scale so we could see that. Could have done that. But if you do that and you don't label your scale, I'm going to assume that you're going by ones. I prefer the scale to always be labeled so that there's never a question. So if you did that, I'd mark it off because how would I know? Okay, so let's talk about this graph. Does the graph appear to be evenly distributed, skewed to the left, or skewed to the right? Because the first S in socks is shape. What would you say? A little to the right, and the only reason why I say this is because that bar, right? So wouldn't you say if you took that bar out that it's pretty evenly distributed? Okay, but that bar kind of messes up a little bit. So I would actually be okay with you saying the graph appears to be evenly distributed, or you could say that it's slightly skewed to the right. Either one to me I would accept because it's just a slight variance right here. So, and we're using the word the graph or the data. Well, let's say the data because I don't know what it is. So the data is fairly evenly distributed. Or you could have said slightly skewed to the right. So you can use words like slightly skewed, heavily skewed, moderately skewed, things like that. So use your descriptive adjectives. Then what does the O mean? Outliers. So when we do histograms, yes, we want to look for outliers. We have, out of 23 pieces of data, we do have 7 out of the 23. Isn't that 1/3 of the data? 7 times 3 is 21. So almost 1/3 of the data is in the 36 to 40 interval. That's kind of significant that we might want to mention that. We also see a fairly significant low there, right? And so that's something that we might want to mention. So even though they're not technically perhaps outliers, in the sense of the true super low versus super high, when you're looking at a histogram, you want to mention really tall bars and really low bars. You definitely want to mention some of these intervals in between could be blank. There's nothing in those intervals. That's possible. You definitely want to mention an interval that's blank. So for here, for outliers, I would say that 1/3, and you can't use a fraction because we're writing sentences, 1/3 of the data, you could have said about 1/3 of the data is in the 36 to 40 range, while only one piece of data is in the 21 to 25 interval, I guess is what I should be saying. So this should be probably interval. Thank you. So we talked about our high, we talked about our low. Then C, central tendencies. So let's talk about what measures of central tendency we could find. Can we find the mode? Well, the mode is the number that appears most often, right? So this is the highest bar, but couldn't there be, you know, 2 36s, 1 37? Well, we know exactly what we have, right? We have 7 pieces of data, we could look at them. The mode is going to be difficult to tell just by looking at the histogram. We do have the individual pieces of data though, don't we? Okay. So the mode could be something that occurs 4 times, right? So the mode could be here or here or here, couldn't it? The mode could have also been something that occurred 3 times, so it could be here. So I can't really tell what interval the mode is just by looking at the graph. But I can look at the data up there. Is it easy to look at the mode with the data up there the way it's stretched out like that? No. I could easily miss something. So, and then our frequency table doesn't tell us, like the stem and leaf plot does, what the individual pieces of data are. So the mode would be difficult to find. Exactly. What about the median? Just looking at this graph, could I find the median? I actually can. Median is actually very easy to find. I'll show you how to find it in a minute. What about the mean? Looking at the graph, can I find the mean? No. But since the data is evenly distributed, I can kind of estimate where the mean might be. Wouldn't you expect the mean and the median to be about in the same place? Since there doesn't appear to be any outliers, no really big numbers and really small numbers compared to the rest of the data. So I would imagine that the mean and median would be in that same place. Since I know the individual pieces of data, could I find the mean? Sure. So we could do that. Bless you. So I would prefer to find the median because I don't have to add up all the numbers and divide by how many I have. So here's what we're going to do. How many pieces of data do we have total? 23. Is there one middle piece of data or 2? Odd number of data. Won't there? I can't split it equally, right? So there's going to be one middle piece of data. Okay? So the easiest way to do this, if I were you, is to take 23 and drop it down 1 to 22. Split 22 in half. What do you get? 11. So we're going to have 11 pieces of data in front of the middle piece of data. Then we're going to have the middle piece of data, and then 11 pieces of data behind that, correct? So the middle piece of data is what numbered data? The 12th piece of data. Isn't this essentially ordered kind of from smallest to largest? The intervals are. So if I count, this is 4, this is 4, how much is that? 8, this is 9, plus 3 is what? 12. So wouldn't my median be right here in that interval? I don't know what it is exactly, but I know it's in the 26 to 30 interval. So here's what I'm going to say. The median of the data is in the 26 to 30 interval. Yeah. Oh, you need that paper. Zach, will you pass this over to Isabella? Okay, so we've done SOC. What's the last S? Isn't it range? So, okay, granted, I know what the individual pieces of data are, but if I were just looking at the histogram, my data ranges from 11 to 40. So if I'm just looking at the histogram, that's what I would say. So the data ranges from 11 to 40. Now that's not necessarily exactly accurate, although yes it is. Is my smallest piece of data 11 and my biggest is 40? If you look at the individual pieces. All right, so questions about that. So we could find the mean if we had the individual pieces of data, which we do. We actually could find the exact median, again, because we have the individual pieces of data, but we can estimate where it is by counting our intervals, our height of our intervals. The mode, not so easy to find by looking at the chart. Oops, sorry. Then you're going to have to do number 2 on your own. So I have an issue with the frequency table in number 2. Can you tell me what the difference is between the frequency table in number 2 and the frequency table in number 1? Tell me what the difference is between those. Say that again. You've got numbers repeating, right? Look at these intervals. It goes from 7 to 8 and then from 8 to 9. And then the 9s repeat, the 10s repeat, and the 11s repeat. What if I have a piece of data that's 8? Where do I put it? What if I have a piece of data that's 9? Where do I put it? Do I have any just 8.0s or 9.0s or 10.0s or 11.0s in here? Oh, there's a 10.0. Where do I put it? There's a 9.0. Where do I put it? Do you see where my dilemma is? And so one of you is going to put it in the lower interval and one of you is going to put it in the higher interval, and we're going to have different frequencies and we're going to have different histograms. So how do you propose we fix it? Because we are going to fix it, because I hate that. And your textbook, by the way, that one of the reasons why I like to rewrite it, it does that too. So how are we going to fix it? We're going to fix our intervals. Yes. That's not going to help me, because I still have to figure out where to put it. Right? So I have to change my intervals a little bit. What do you want to do? Perfect. Can't we go from 7 to 7.9? Normally it wouldn't matter. Well, you could do like 7 to 8 and then 9 to whatever, but we have decimals in here, don't we? So we have to include those decimals. But you also have to make sure that your intervals are the same width apart. I can't have one interval that's 10 units apart and one interval that's 9 units apart. So when you fix them, you have to be careful of that. So I will agree that we can go 7 to 7.9. So that means if I change the 8, won't I change the 9 to 8.9? And 10 to 9.9? And the 11 to 10.9? And fortunately, we don't have any 12s data, so that's good. So the 12 becomes 11.9. What if I did have a data item that was 12? What would I have to do? I'd have to add another interval, wouldn't I? And what would that interval be? 12 to 12.9. You might only have one piece in that, but that's the way it goes. All right, so you're going to finish that on your own and do just what we did on this one. So flip it, though, because I want to explain one more thing to you. So then the whole back is really more about you reading the histogram. So this one, you're going to actually read the histograms and compare them. Look at the titles. It's going to tell you what's going on. You've got hours of sleep per night for Wheatland students and hours of sleep per night for Urbandale students. Some of you get lots of sleep. Some of you get no sleep, right? And this is almost a nice, perfect bell curve. Do you know what a bell curve is? Looks like a bell, right? Starts out low, gets high, comes back low. That's called evenly distributed. Evenly distributed, the middle can be high, because that's a normal distribution. And we're going to talk about more what's normal distribution, what's standard distribution later. This is also fairly evenly distributed because it's almost a bell curve also, right? Just a little, if that one were a little smaller, it'd be a perfect bell curve, right? But to me, this one is evenly distributed also. So these graphs are not skewed to the right or to the left. So that's one thing. Where would you expect on a normally distributed curve the median and the mean to be? In the middle. So I'm guessing probably my median is going to be here. And these, by the way, are not really true intervals the way they've written them, have they? No. They've just written one number. So this is 0 to 1 to 2 to 3. So this is really 2 to 3 hours, 3 to 4 hours. So if a student actually slept exactly 3 hours, do you see where the problem here is? So maybe they're doing 2 to 2.9, and then 3 to whatever. So again, I have an issue with how they labeled it, but we can't change that. But the question, I'm going to just talk about question number 3, and then I'll let you do the rest of the questions on your own. It says, suppose that the 2 histograms above show the sleeping habits of the teens at 2 different high schools. Wheatland High is a small rural school consisting of 100 students. So you know how many pieces of data are in the left graph, right? And if you added up all those frequencies, or the frequencies are actually what on the vertical scale? They labeled what the frequency meant. What is it? Percent of students. So it's not number of students. They gave you the percent of students. And the reason why they did that was because Wheatland has 100 and Urbandale has 3,500. So if they converted the numbers to percents, can't you compare percents versus 100 and 3,500? So that's why they use percents. So do pay attention to what they're talking about. So it says on number 3, about what percent of the students at Wheatland get at least 8 hours of sleep? So let's figure out the height of our bars. What's the height of this bar if it goes from 0 to 10%? And we're going to have to estimate. What would you think that might be? 1 or 2%? Let's go with, we'll just call this 1%. I'm going to put a 1 up there. We could argue for 2 if you'd like. If you're not writing, that means you're sleeping on me. What are you going to call this bar? I might even call it 3, because halfway would be what, here? So sometimes your ruler's a little helpful. Halfway would be here. Couldn't you see that as being 3? Okay, so I'm going to call that 3. This one's easy to name. What's that? So that one's 10. And then this gets up to at least 8, right? So this is my last bar that I'm going to consider, because here's the 8 that I'm looking at. So how tall is this one? If this would be about halfway. Yeah, so we're going to go with 45%, right? So then we need to add those up. So we've got 1 plus 3 plus 10 plus 45%. How much is that? 59%. Question? Oh, thanks. Yeah, that would be exactly that. Thank you. I'm not quite awake yet. She has a good point. If it's at least 8, is that greater than 8 or less than 8? Look at that poor kid who gets, well, I guess that's me. I get 5 hours of sleep a night. So if we came up with 59%, then what's the rest of this must be at least 8, right? So then at least 8 would equal 100% minus the 59%, right? So what does that give you? What does it give you? 31? Oh, I was going to say, because that's not going to give us enough. So 41%. So this is below 8 hours. All right, so then you're going to have to, and then make sure you're looking at the right graph. So then the next one you're going to do is for Urbandale for at least 8 hours. And then you're going to go ahead and talk about this. You're going to have to find the median sleep time for each high school. So it's just what I taught you how to do. So percents are based upon what? 100, right? Each of these bars should add up to 100. So you're going to have to find out this bar height, and this bar height. If they don't add up to 100, you're going to have to adjust some of your estimates, right? And on a question like this, I would take an answer within a range of values, because you might be off 1 or 2 or 3%. And I would understand that. But when you're looking at the entire bars total, you need to make sure that they add up to 100%, because this is based on 100% of the students that they surveyed. So when you're answering this question right here, you might have to adjust some of those bars that we talked about. Perhaps one of them by 1 or a couple of them by 1. I think in the answer to this, you ought to be able to talk about this. You're going to have to compare. So you're going to have to use your socks when you compare the shapes. Compare this shape to that shape. So my comparison for their shapes is what? Same or different? So you would say both Wheatland and Urbandale students sleep hours are evenly distributed, is how I would say that. Because you're talking about sleep hours, right? And then, so you compare it that way. Then outliers, if they're evenly distributed, would there be really any outliers? No, not in that sense. But you do have some very high numbers, right? And some very low numbers. So you're going to want to talk about that. So you're going to want to talk about that, you know, Wheatland had 45% of students that had between 7 and 8 hours of sleep, while Urbandale had only, what, 20, maybe 3% of students that had between, or if we look at 7 and 8, you're going to want to compare comparable bars. So if that highest bar is 7 and 8, theirs is actually less than that, right? So they had about, what, 18% that's between 7 and 8 hours of sleep. Do you want to kind of compare those bars? They had 1% of students that had from 2 to 3, whereas Wheatland had 1% of students that had from 4 to 5 hours of sleep. So you can do kind of something like that. So it's going to be kind of big, so make sure you write small. And then number 9 is very similar to the last question that you had on last night's homework, where you have to create a frequency table in a histogram that is skewed to the right, meaning you have more items in the smaller intervals or the bigger intervals? The bigger intervals. So you want to make sure you have that. You want to make sure that your median lands in this interval. So aren't they telling you the interval width? 50 to 59? That's actually a width of 10. If you count on your fingers, 50 to 59, it's not 9, it's actually a width of 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't that a width of 10? So your widths are going to look like, you know, perhaps 10 to 19, 20 to 29, that kind of thing. But you have to figure out which interval you'll start at. And then you have to have a range of 70. So if that's in your middle, you can only go, that doesn't mean you have to go up to 70. You could start at maybe 30, but you'd have to go up higher than 70 and make sure that that width is 70. So you have to play around with it. You just have to meet those 3 things. Skew to the right, medians in the 50 to 59, and the range of 70. You don't have to give the individual pieces of data, but you do have to tally and do frequencies, and then make your histogram. But don't make the histogram until you have those things done. Obviously, we're doing it in pencil, so you can erase and you know, mess with it a little bit. Questions? All right, good.